Hey there from sunny Central Florida, Ace Mentor. We're excited to share our virtual design and construction engineering technology, Ace at Home. I am Travis Colbjornson, Chairman for the Ace Mentor of Central Florida program, as well as Business Development Manager with Barton Mallow Builders. Today we have a trifecta of talent that includes Adele Shalaby from Rhodes and Brito Architects, Lee Slay with Barton Mallow Builders, and Andre Tusignot with PCL Construction. And also with our team is Nick Pepe. He's actually the mentor leader for South Orlando and been leading a big group of kids down there. He's going to talk a little bit through the homework tutorial and what you'll use as kind of a practice of what you've learned today. They're going to show you today a little bit about how they utilize these tools that support the ways we move through the design and construction industry.
Thank you, Travis. So my name is Adele Shalaby. I'm an architect. I have about 20 years of experience in the architectural field. I will be going through the design process and how we utilize this technology that I'm going to mention today. This is an example of a project that we've worked on. This is in Heritage Park outside the Orange County Regional Center. The task from the county was to try to figure out what's the best way to provide some more curb appeal to the building, and given that the existing location had so many trees in it. So what we decided to do is to scan this location, all the trees and everything out there, to try to figure out what the existing conditions are before we investigate what the proposed designs are going to be. So this is a quick video showing the point cloud, which is, in other words, a way that a camera can scan the space, and it provides you the data that is in that space. So all these little dots, it's information that is collected all over by the 3D cameras that are placed there. And if you see, you can zoom in and actually see the space in 3D. I'm going to spin through it a little bit. You see those little orbs that are located in the middle. Those are actually where the camera are located. And if you click on them, you can actually see some of the shots that are there in that location. So we took that information, that digital scan, and we converted that into a conceptual design that allowed us to come up with different ideas. We took that information after that and we provided a SketchUp model, taking the 3D data that was provided from the scan, and we developed a conceptual design that we were able to use. I'm just going to play on it. So this is actually a scan of the existing conditions. We were able to model it, all the trees, what was there, what was the existing conditions. We started trimming some of the trees out to improve visibility, so we were able to see the building in a better way. We were able to get different shots. We provided some design options for the client to better understand how they can utilize this space. And this is some cool ways to look at your design in different daylighting conditions. So this slide shows, the top picture shows the existing conditions. The bottom one shows a day shot, and it was rendered in SketchUp, rendered and put in a filter that shows it like watercolor. Seeing what we've done once we've reduced some of the trees, allowing visibility to the building, and it gives you a different look of what the building is going to look like. And this is a different shot, the night shot. We provided 2 bus stops at that location. This is another day shot for the existing conditions. This is what we were able to do by reducing some of the trees and providing a new entry feature and signage that was put at the edge here. And this is kind of a night shot for it. And we provided some sculptures, again, give them ideas of what they can utilize the space, see all the trees that were there, and we were able to utilize the scanning technology and the information we provided in the proposed concepts using SketchUp to give the client a better understanding of the space. The other sample I'm going to show you is from the convention center. The task here, and this was an actual picture from the space, the task here was to enclose the space above and create office space. So it's very hard to try to measure this by hand and try to figure out what's going on. So what we decided to do, we took a scan of the space. So this is an actual scan of the space, a 3D scan of the space, utilizing a Leica camera 3D scanner. And we provided storefront glass in here to enclose this, and that becomes the new office space above. So this is a scan. We have multiple scans, and this is using a program called Recap. It takes the digital data that we provided from the scan, and it stitches it together so you are able to actually go into the building and visualize everything there. You'll see that you're able to actually take dimensions to verify dimensions. And this is the orbs that I was talking about. If you click on one of those orbs, it actually takes you to the 3D picture that was taken in that space. And you can see along the line here, we've got number of camera shots that you are able to take and do it to a 3D view. So if you look at all these little orbs that are here, this is different locations that we took the scan. You are able to have superpowers or get into the walls once you transform into the point cloud and are able to see everything in there. The importance of these dimensions, they help us to measure the existing conditions live. I don't have to keep going back and forth the space to do this. I'm able to do it remotely when I'm in the model. Then I could take this information and prepare a computer model for it. In this project, we decided to utilize Revit because the intent was to provide construction document, not just conceptual drawings. So what we ended up doing, utilizing the scan, and here you see that at the bottom, we are playing with the existing conditions. You can turn on different filters, so you can see this is the existing building, and we start adding the phases of the work so we can phase what we are trying to present to the client. It gives them a better understanding of what they have, what they expect to the final product, and build the project in the virtual world before it goes to construction. This gives you a whole lot of different ideas of what you can do. Going through these shots, it shows you a 3D camera of what you can be looking at. You could render this, you could cut sections. So again, it allows different levels of flexibility for you to show this to your clients and the end users when they're understanding the project.
My name is Lee Slay. I'm with Barton Mallow. I'm a VDC engineer too. I have 4 years of experience in the construction industry, and my background is in design and architecture for my bachelor's and construction management for my master's. And I'm going to be talking about constructability reviews and a couple of different ways that they can be done. What is a model constructability review? So this is meant to complement traditional constructability reviews, which are typically done in 2D. So typically our estimators, our planners will look at a drawing in 2 dimensions on a PDF or just flat on a computer screen or print it out and go through and see if there's anything that stands out, that doesn't quite look right. They'll make notes by hand, things like that. So constructability reviews in 3D are completely different. They look at the design from a different perspective, like you're in the space. It's a unique tool to help prevent future RFIs or cost change orders. And we're essentially looking for issues that can be designed out rather than worked around when we're in the middle of construction. So we're trying to get ahead of all of the problems that could possibly come up, especially really big issues that we're not seeing until it's too late. So in general, a comprehensive review of all of the systems together. And then on this next slide, here's just a quick example of an image. This is a screenshot from a program called Navisworks. This is a 3D coordination review program. So it takes all kinds of 3D model files and puts them together so that everyone's systems can be reviewed in a 3D space. So here you can see that some of the plumbing pipes are going through the steel beams. They're running through the building and hitting in multiple locations. And we use programs like these to keep track of these problems early on, address them with our design teams, and get ahead of them before we're in the field and trying to come up with a solution when we're on crunch time and we have to get this project done, and now there's a pipe in the middle of a beam, and what are we going to do? So there's a couple of different programs that can be used for constructability reviews. On the left side, this is a web-based application called BIMTrack, and it's an app that plugs into Navisworks, which I just showed you earlier. And this program essentially takes viewpoints from Navisworks where clashes or points of congestion, areas that are conflicting, have been saved in the program. So essentially little pictures. and they're exported to BIMTrack, and a record is kept in BIMTrack. And you can see there's a summary that it keeps, and it's all color coded. So blue means it's a low priority clash, and then it goes all the way to red, which is a high priority clash or problem. And it keeps track of this versus how long it's been active, if it's been resolved, how many issues there were on that particular day or week. And usually over time, the issues may increase, and then once the trades and the team starts working on these issues, they begin to decrease. So the colors will change accordingly as coordination goes on. On the right side is an example of the clash detective from Navisworks. So this is a part of the program where you can tell the program, hey, I want to see if there are any problems with the mechanical ducts and the plumbing pipes. And it will find those systems. It will do essentially a 3D scan of the model in 3D space and see if those two systems are hitting each other, if they're touching or if they're within a certain amount of space within the building, and it'll mark it as a conflict or a clash. And it allows us to review those later on and present them to the design team, to our trades, and so we can work through them ahead of time. The other option that we have for 3D constructability review is laser scanning, which you saw some examples of that earlier on. And what we have here is an example of a medical center renovation. This is Holmes Regional. It is a 30,000 square foot renovation project, and we laser scanned the entire floor. So there were actually about 20 scan locations, and you can see here a couple of different pictures from recap over here in the bottom right corner, and above is more of a specific space, and then on the left side it's the panorama view of that space kind of stretched out before it's been folded or wrapped around so that you could see it more of in the way that you would see it if you were standing there physically. So when we did this project, we noticed when we went out to laser scan, because it's easier to tell the current conditions for a renovation if you scan instead of having someone run around with a measuring tape and sticks and paper trying to keep track of all the measurements and where everything is. It's obviously easier to laser scan. So what we found out was there was a 2-foot discrepancy between the existing structure and the drawings that we had. And you can see these from the little markups, the little circles. There's some pretty big changes there. So we were able to determine that the design models and drawings were off from the reality. So this allowed the design team to adjust their drawings before we went into construction, after the field verified all this data. So that saved a lot of time, saved a lot of money on the front end of this project, and a lot of heartache for the design team and the construction team. The other version of constructability reviews, we can also do this with drones. And this is always a cool, fun way to get out on site, talk to the team, and how everything is progressing. The great thing about drones is that they provide so much information in just an image. They're able to provide terrain model data. You can overlay images, so you can get a PDF drawing of your current project and overlay it on top of the pictures that the drone has taken, and it'll help locate utilities. Is quality control for active construction. You can see, okay, this is where we're at, this is where we should be, is this footing in the right place, here's the future location of an elevator pit, here's some utilities, things like that. So it helps us get ahead of any potential problems that may happen in case we are noticing that maybe things aren't being installed in quite the right spot, or if we're seeing utilities underground that maybe weren't taken into account during the design process, or we're in a slightly different location than expected. So this helps save time and money on the front end as well. When the time comes to build the building out of the ground and start putting up walls, we know where everything is. Everything has been accounted for ahead of time so that there are no surprises.
I'm Andre Toussaint. I'm the virtual construction manager for PCL in Orlando. I've been working in construction here for 15 years, and my background is actually in civil engineering. I have a bachelor's degree in civil engineering from the University of Florida. So let's talk about how we can use some of these 3D models and some of these other technologies during construction. So one of the first things that we'll do is go through a very detailed 3D coordination process. So the steel manufacturer, all of our mechanical, electrical, plumbing trades will take all of those design models and, they'll kind of plus them up to really take them to almost a fabrication level that they can ultimately use to build the structure. So what we then do is we take all of those parts and pieces and put them together to actually coordinate all of the space, even further before we actually start building the structure itself. So next slide here, this is just a couple snippets from Navisworks as well, where again, we're building everything virtually before we actually put the real thing together. So in a commercial space, such as this example of a large restaurant area in a hotel, we may include a lot of lighting fixtures or even furniture, so that we can go ahead and we can determine the final location of, say, specific items inside of a ceiling so that we can maintain, sort of the design intent that was meant. So you may not think about it when you're looking up at a ceiling, but a lot of times there's a lot of thought given to where those fixtures need to sit in relation so that everything is symmetrical along with all of your HVAC ducts and everything along those lines. So the next thing that we will also do, especially when we get into building, is we will take a lot of those design models as well and we'll turn them into actual plans that we can further detail out to build with in the field. So inside of Revit, again, you notice a lot of the same software, a lot of the same technology being used through all phases of a job here. We're taking this really complex couple levels of this tower structure where you have a parking ramp going in, you have a number of pieces of interfacing with each other. And we're kind of creating just a very simple color coordinated construction sequence just to be able to better show the order of how things are going to go together. And then what we'll do from there is, we'll take this overall view and we'll split it up into each individual piece. And we'll show all of the additional details, information that we need to actually build this out in the field. Now, on the next slide here, we have a similar situation. We have a 3D model of, this top of a tower, but sometimes digital is great, but sometimes it's not nearly as good as actually having something physical that's in your hand. So believe it or not, yes, we even as contractors, we still will 3D print objects, especially here. This particular top of the tower was really trying to get everyone a very good understanding of how the pieces all actually had to fit together and what it would look like when it's done. And the picture doesn't really do it justice. This model is probably about 2 feet square, and you could take each level off. So even though all of this, the digital models are great, just having something physical is really still beneficial for a construction team. The next example here, this is a bridge job that we had down in South Florida, and we had a lot of existing field conditions that we had to work through. So just like we had laser scans done during the design and pre-construction process, here we did laser scanning so that we could actually as-built this dock that's on the left side of the image. And the whole reason we had to do that is we had a couple very large barges with cranes as well that we had to fit into a fairly small area. And the last thing we wanted to do is move any of these barges into position, especially around some of these very expensive boats that we had nearby. So this is a case where, again, we took that design model, we added some more information to it. We've put some crane models and some of the other parts and pieces in there so that we can physically plan everything out before we actually get into building it. Then we take this model, and on the next page here, now we've actually turned it into a full work plan where we've got all of the particular details, the exact sequence, all the kind of things that you would need to be able to actually perform this lift out in the field. And on the next slide, this is an aerial image of, that exact work actually happening. So you see, we've really come full circle here, not only with the technology, but just with the 3D models in terms of making things, real. Now, another thing that we can actually do with the models is we can actually use that to lay out the structures in the field. So unlike just a traditional surveying, which a lot of times they would be dealing with maybe just specific points, we can actually push those models into some of the software, some of the surveying equipment that we have, and that model will basically generate all of the points that we need to lay out a structure. So the example on the left here, this is a curved wall that has some varying elevations to it. And you see each one of those gray dots is actually a survey point that we can go stake to and lay out. So rather than manually calculating all of this information, we're letting the model do all of that for us. Very similar example on the right, where this is just what seems like a very simple curb layout for a parking structure. But to go out and lay that out traditionally would take a lot more time versus here, we push the model out into the field and we can quickly generate all of these points, all the information we need to go ahead and lay it out and successfully build it. Now, what do we do once we've actually built it, right? We still have to verify that what we've built is correct. So that's what on the next slide here. Again, using a lot of the same technology here, we're using laser scans to actually verify what is built matches the tolerances of what we're allowed to build. So in this case, this is a bridge structure about 100 feet wide, about 90 feet in the air. And all of the concrete formwork that's supporting this, right, believe it or not, when you pour concrete into formwork, that formwork does move. Now, mind you, it may only be fractions of an inch, but in some projects, you can have very tight tolerances where fractions of an inch really add up and matter. So in this case, to actually verify that this really large structure was still within the allowable tolerances, what we did is we went out and laser scanned it and compared it to the model. And that's what you see here is the varying colors are representing, how far from the design the certain areas are. So we could very quickly verify that all of the formwork and everything was moving and setting just the exact way that, the computers predicted that it would. The next slide here, again, Lise mentioned earlier using drones for verifying progress, right? And of course, we're definitely going to continue to do that through construction. So it's important to note, that when drones are flown in a lot of AEC projects, right, we're not just generating just simple photos or just simple videos. As mentioned before, we're actually generating models from all of these photos. So in the example here, you see on the left, this is the actual color image. And on the right, that's the actual 3D model that was generated from that drone flight and all of those images. And this exact same technology is used in a lot of other industries as well. A lot of video game companies will actually use this. So if they have to model an existing building or an area, they can do it a lot quicker this way than they could traditionally. And we're even seeing films nowadays where, same thing, they need a model of a certain structure and they can use this to get that information a heck of a lot faster. So the next slide here, this is an example of where we've used that drone data. We've overlaid it with the design, and we're using it to verify that some of these curved walls on this hotel job are actually in the right space. So yeah, we could go out and we could use traditional survey, and sometimes you still need to, but in the case here, we can capture a lot of information very rapidly and compare a lot of design information very rapidly as well. With that, that's all we have on construction.
Nick Pepe here, speaking from PCL. Wanted to bring everything into a close. We've seen some presentations from the architecture, the design side of life. We've seen some presentations for the pre-construction and how to deal with different class detection. We've also seen from the construction side of life where you can use drones to fly and get real-life modeling. Now, something I did want to point out to the students is the fact that we have 3 different professionals with 3 different degrees, all using very similar programs. They're all using Revit, they're all using Navisworks, they're all using drones. So they all have very different backgrounds, but they're all coming together to use this new and advanced technology in very different ways to solve real life problems in our industry. So that's a very, very great opportunity here. Now we're going to go ahead and get the activity started. Now this is a 1-point perspective. What you're going to be doing is you're going to go ahead and follow the YouTube video. From there, it's very simple. All you're going to really need is a writing utensil and a straight edge. So either a ruler, a notebook, whatever you need to do. Go ahead and follow the YouTube tutorial step by step to see how 1-point perspective plays into the design and the pre-construction side of our industry. Additionally, once you go ahead and complete your masterpiece, if you will, go ahead and upload it to your favorite social media, either Facebook, Instagram, Twitter, and tag hashtag AceVDC. So once this presentation gets out, we're going to go ahead and share a couple of the ones that are very popular. All right. Thank you again.